What's going on, everybody? Jesse here, and welcome back. In this new series, we'll be taking the inventory system and converting it into C++. In addition, we'll be writing the inventory system into a personal plugin that can be easily added and adapted to any other Unreal project you have now and in the future. Writing a plugin is relatively easy, but it will test your object-oriented programming skills, forcing you to think inside the box in order to keep your plugin universal. Some of the many things you'll learn along this journey will be how to write and package a plugin, how to prototype your project in blueprints and convert them to C++, how to communicate between C++ and blueprints, and so much more. Because I've already explained my reasoning in designing the inventory system the way I have, I won't be doing that in this series. If you need to understand my system logic, then I encourage you to watch my blueprint series first. Link is in the description. Instead, I'll be focusing on explaining the C++ side of the system, from syntax to design to implementation. We'll also be doing some refactoring of the code along the way, either because I found a better way, because it may be different in C++, or simply for optimization purposes. We should always be looking to refactor our code when possible. Leading up to this series, I've created a fundamentals playlist, which was designed as a primer for you to be ready for this series. Should you have any questions that were answered back in those videos, then I will simply point you back that way. Anything taught there will not be reiterated here. As we move forward, I may on occasion add more videos to the fundamental series. Throughout the series, I'll be using source control. I will also be using the Writer IDE. I understand that many, if not most of you, will not be using Writer, and that's okay. Get to know your IDE and how it operates, and you'll be just fine. However, there are some things that Writer does for me that you won't have in another IDE. For example, Writer, for the most part, automatically includes the appropriate header files for me when I call on a function. I don't always recognize when this occurs, but if you're following along and you get an error or the red squiggly line at the function call, then you can expect you will need to include the appropriate header file. I'll do my best to let you know when this is needed along the way, but you should get comfortable with finding this information yourself. One of the best resources in this regard is, believe it or not, the Unreal Engine documentation. While the documentation in Unreal has always been subpar, when it comes to C++ API, you'll find everything in the documentation. Link is in the description to the C++ API. When you look for a function, class, or constant in the API, the corresponding page will show you where the files are located in source code, as well as what the include file is that you will need to put into your file. For the most part, it will also show you what variables or functions are available to you when using that include, which can be helpful. Take a look at the API and get comfortable with using it because you will need it. When I did the original Blueprint series, it was in version 5.2, but I have since upgraded to version 5.3. While this shouldn't make any real differences, if you notice something different or you're running an older version, then consider updating, but I don't suspect that there's any real differences with what we're doing in this series. Let's go ahead and jump into the editor now, convert our existing project to C++, start our plugin, make some adjustments, and write our first function. Today's episode and others just like it are brought to you by the patrons listed on the screen. If you'd like to support the channel and future development, then consider visiting my Patreon or Buy Me a Coffee page, where you can receive various benefits such as early access to my videos, project downloads, as well as personalized support. You may also want to consider joining the community by joining my Discord server, where you can receive help from me as well as the community. So come on over and be a part of the conversation. All right, so I'm in a cloned copy of the previous survival series that we were doing in the previous series. And the reason why I went with a clone was because in the last one, it was working pretty good, and I don't want to mess that up. I want to have something to go back and look at in case I do something to this, I mess it up. I'll have a good project to do that in. So you don't need to do that, but I would advise whenever you're making multiple iterations or making some massive changes, if you're not using version control, then go ahead and create a clone of your project and work in that when you're doing major changes, and then just update your original if you want to. All right, so like I said in the intro, we're going to go ahead and turn this inventory and crafting system into a plugin. So how do we create a plugin? How do we start? Where do we go to? So if we come up here to the edit tab and select plugins, if you're in 5.3, you're going to have this add button here in the top left-hand corner. If you're in 5.2 or below, there's probably going to be a button down here in the bottom right-hand corner that says add new plugin or something like that. Either way, select either one, whichever is applicable to you. I'm going to select add, and you're going to see here when it pops up, all we have is an option for content only. There's different templates for plugins, but for some reason we only see content only. Well, the reason for that is because our project isn't actually in C++. So really the only thing we're allowed to make in a Blueprint project as far as a plugin goes is a content only. This isn't what we want, although we will be able to add content, and I'll explain what content is within the plugin a little bit later, but this is not what we need. So we need to go ahead and convert our project into C++. Converting our project is not very difficult to do. All we need to do is if you come up here to Tools, you're going to see the first thing that pops up. It's going to say New C++ Class. Go ahead and select that. And then you're going to be presented with a familiar pop-up window here that asks you what base class you want to base your new C++ class off of. There may be a couple extra things in here that you didn't have in the blueprints. That's fine. But for us, just to start out right now, we're going to create a whole bunch as we move forward. But for right now, we're just going to go ahead and start with the game mode base. So go ahead and select that and then hit next. When the new window pops up, don't worry about public and private, just leave those as it is. And right here, go ahead and give your new class a name. I'm going to just call mine generic game mode. Okay. And you'll notice with me in my C++, unlike blueprints where we preface everything with BP and all those other identifiers, is I don't do that with the C++. I don't think that's really convention. I haven't seen that really anywhere else, even in Epic's own code. So I'm not going to do that with my C++, but we will be doing that with the blueprints. You'll see as we move forward. Next is you're going to be presented with this box here, and I'll explain this. Right now we only have one choice, and that's the your main project runtime. So go ahead and leave that there. And then the path. We'll talk about the path a little bit later. Do know that moving files around in C++ is not as intuitive as it is in blueprints. So it's highly recommended that when you're designing your file structure, you kind of try to stick with it. Design a good file structure, stick with it, and just go along with that, because moving things around is not very intuitive in C++. All right, and then right here it's going to tell you it's going to create a header file, and it's going to put it in this folder, and a source file, which is your CPP in that folder. So everything looks good here. Named it, go ahead and select create class, and this may take a minute. And then when it's done, you're going to get this pop-up here that says project now includes sources. Please close the editor and build from your IDE. So go ahead and select OK, and then you're going to get another pop-up advising you that you do need to compile from C++. Do you want to edit the code now? If you select yes, whatever you have set as a default IDE will open up. If you don't have a default IDE set up, then all you need to do is go into your editor settings, go under source control, and there's going to be a drop down in there that lets you select your default IDE. So if you're using Visual Studios or Visual Code or Writer like me, you can go ahead and select that from the list there. And every time you compile or call it to regenerate code from source, it will open up your appropriate IDE for you. So if I select, would you like to open the code now? I select yes. Project not available. Generate project file. Yes. And then once that's done, your IDE should open up. If it doesn't open up for you, then go ahead and just open up your project file, go to your main folder that has your project in it, and you'll see the .sln, the solution file in there. Double click that and it'll open up your IDE. Once in there, give it a chance. Everyone, regardless if it's Writer or Visual Studios, it will need to index and process all the files. Go ahead and give it a minute until it's ready to do that. Here in Writer, in about a couple seconds, it's going to give me a pop-up saying it's ready to use while it's indexing. There it goes. It pops up, Writer's ready for use, but it's still indexing. So I'm going to let it go ahead and process all the files before I do anything. So just go ahead and wait. And while you're waiting for that, go ahead and close out. If you haven't done so already, close out the editor that you were in. So that way we can go ahead and compile and we'll run it from your IDE. All right. Now that your IDE is opened up, it should have opened up to your new file, which for us was the generic game mode. If it didn't open up for you, then go ahead and just open up your IDE, whatever it might be, and then open up your solution file, which should be located in your project file, the .sln. That's your solution file for your IDE. Open that up. And then when you come in, you're going to be presented with your solution on the left. In the game folder, you should see your project, which for me is survival CPP _YT, and then everything in here. So we got our files here. They're going to be under the source right here. So we see source, and then we got our project name folder right there. Open that up and you will see our initial files that we have available to us. So first thing we need to do is we need to go ahead and compile our code or build it from source control. So for me, I got a little hammer right here. It might be the same for you in your IDE, but just find your build tool and go ahead and select build. Make sure that you have your project, your editor closed before doing this. So go ahead and close that down if it's not done already, and then hit build. And then when it's done, you should have a build succeeded somewhere pop up on your screen. Make sure when you're opening up your IDE as well, you'll be, it'll take some time for it to load up. Let it index and do everything it needs to do before you get to this step. Once it's done loading everything up, then go ahead and build it. All right, now we can go ahead and run our editor. And for me, usually I try to run my editor from within the IDE. There's going to be a lot of times when updating your C++ files that it doesn't actually update into blueprints. So which means we have to close down the editor and open it back up. And running it from editor really isn't that bad to do, but it's a constant back and forth. Hot reload isn't the greatest thing in the world. It does what it can, but it's still pretty limited. So get used to running your editor from here. For me, I've got a little play button here. By pressing this, it's going to build the project again. So I didn't really need to press that build. I could have just pushed this. It's going to build it before it runs it. And if it succeeds, then it goes. We haven't done anything yet, so everything should be successful. Go ahead and play it and open up your editor now. All right, now that it's loaded back up. Now if we open up our content browser, come down here, and now you should be presented with a whole new folder structure here, C++ classes. We are now officially a C++ project. And then if you go down here and you select your folder, you're going to see that we have the generic game mode right there. It's labeled it as a C++ class. So now we need to go ahead and create the plugin. So now if we go back up in here into the edit, select plugins, it's going to open it up here. Now if we hit the add button, you're going to see an entire list of options that we have. Most of the ones we have in here are for editors. You can make your own editor plugins, to do whatever you want within the editor. But for us, we're going to go ahead and select blank. And I'm going to come down here. The author is going to be me. I'll just put my first name here. Description, open up the advanced, and it's going to give you some options here. So author URL, I'm just going to go ahead and put in my YouTube channel there. You don't have to do any of this if you don't want to. Is beta version false? We're going to change a couple of this actually inside of the IDE, inside your IDE editor. And then go ahead and make sure you give it a name here. This is going to tell you the folder it's going to go to. Leave this as default. You want it to go into your plugins folder here. So just leave that as default. And then the plugin name, I'm going to name mine TPG for 3-prong gaming _inventory system. Name it whatever you would like, and then select create plugin. And don't be alarmed if it takes it a minute for it to finish, but once it's done, you're going to get it's going to open up your IDE again, and you'll see a new folder pop in here. You should notice it says plugins. If we drop that down, we now have our plugin information right here. So now if we open up the TPG inventory system U plugin file, we're going to be presented with a lot of the stuff that we had really when we were creating it, with just a little bit more information there. So you can see where I put in my YouTube channel right there, my name. You can give it a category if you want. I'm going to give it a category of inventory, and your description. You can type whatever you want in there. Friendly name. I could change this right now to be a friendly name or whatever I want to call it. And for me, I'm going to change the version here. You don't have to do any of this if you don't want to, but I'm going to go 0.1. And then let's go ahead and build this now. And because we're running, go ahead and hit cancel. I usually don't hit the stop button from in here. I don't know how it is in Visual Studio or Visual Code, but when I hit the stop here, it's almost like a hard interrupt within the editor. So when I load it back up, it thinks it crashed. So I don't usually do that in there. I just close the editor by hand. I just come in here and hit the close button every single time. Then I wait for it to finish. And then once that's done, let's go ahead and build it now. And then once again, I'm going to hit play. I'm going to open up the editor. Now, once we're inside the editor, I'm going to open up the content drawer. And now you're going to see another file structure system here under the C++ class. Let me go ahead and expand this out. And it is called plugins. So all the plugins you have are going to be listed here. Okay. So now we have this one folder called TPG inventory system content. Let me explain to you what content is really fast. I kind of touched on it when we were looking at the types of plugins that you can create, where the original option was just a content. What that means, and you're going to see as we move along, if you have things for your plugin, the reason why, if you notice here, this is actually within the plugins folder, is because this is additional content that you want to include with your plugin that is not C++ code. All right. So That means if you have a blueprint, it's okay to have blueprints in addition to your code. We're going to end up having a couple blueprints in here. You'll see as we move along, because I want to have some base items that the player can derive from. So we're going to put that in here for them to derive from those. And things like images, textures, materials, anything that's not C++ code, you can put in here and it will be included with your plugin. Anything of that nature that is not C++ code, put it in the content folder here. Don't put it in any of the lower folder structures. All of our other plugin folders, they will show up here underneath this or alphabetized within here, but all within the plugins folder. So remember, content is for anything that is not C++ related, but you want to include with your plugin. Okay. And we're going to create a lot of stuff here that is in the regular C++ class. Now remember the difference between here as we're doing our work, the plugin, this is only the stuff that's going to be included with the plugin. So as we're designing the plugin, we want to try to keep everything as modular as possible for the plugin. We don't want to have to rely on anything outside of it. But here within the regular C++ class, this is the actual project. So we're going to build a survival game, whereas in the plugin is going to be something that's standalone, but that the project itself is relying upon, just like any other plugin. If we did Paper 2D or something like that, right? That's a plugin. Our project is relying on that plugin. Same thing with this. We're creating this plugin. Our project is going to be reliant on that. So everything within the C++ class and up here in the main content folder, that's all part of the project, not part of the plugin. Okay. So just try to remember and differentiate that all in there. That's why there's no content folder here in the C++, because everything up here, that is all your content. So with that now, before we create any actual C++ other plugin information or classes or anything like that, we need to make some changes back in the IDE. So let's go ahead and jump back into there. So go ahead and bring up your IDE. All right, now that you're back in there, I'm going to go ahead and I'm going to close out the uplugin file. We don't need that anymore. So now we need to find the build.cs. There's actually going to end up being two of them. We're going to need one for the game. So right now we're in plugins, source, and there's the TPG inventory system build.cs. And this .cs means this is actually a C# file. You'll see there's some C# stuff within the Unreal Engine. Not too much, but some there are included in there, mostly with these build files and these target files, things of that nature. They'll be C#. We don't need to know how to code C#. We just need to be able to add some modules and things like that. So now if we come back in here into our source, we're not in our plugins. I'm going to close plugins so it's a little bit more visually understanding. And then I'm going to come down here to the build.cs, survival CPP-YT build.cs, open that up. So now in the survival, the original game project, we need to make a couple changes here. Okay, so now what these are the modules that we are going to include. These are by default core, core U object, engine, and input core. We need to add a couple more. So I'm going to go comma and in parentheses UMG. We're going to add the UMG. Again, that has to do with the widgets and all that, comma, and I'm going to add enhanced input. I don't know why this isn't on by default at this point because they're getting away from the old input, but you need to include enhanced input if you're going to be using it, comma. And then lastly, we're going to add our project these are, again, modules that the project relies on. So by putting them in here, we're now going to have easy access to those header files and those source files for our project. Okay, so with that, we created a plugin. So now just start to type your project name, TPG inventory system. There it is. I'm going to hit enter and now we have it. So the last thing we need to do in this particular folder is you come down here, you can see this is commented out. It says uncomment if you are using Slate UI. We will be in fact using Slate. So I'm going to come down here and I'm just going to back up and get rid of that comment file there. Private dependencies, it has Slate and Slate core. So for now, that's all we need within this folder or this file. So if you can save it, go ahead and save it. Mine automatically saves, or I can force save it by Control-Shift-S. Go now into your plugin build CS. And again, in here, we just need to make a couple changes. So we've got down here in the public dependency module names, we have core. So it tells you you can add other public dependencies that you statically link with here. So what else do we need? After the comma, hit enter. We're going to put in input core, comma, and then we're going to add UMG again because our plugin will rely on some UMG functionality and codes. And remember, this is within the plugin. So even though we just entered it in the other one was for our primary project. This is all for the plugin to be able to have access to these modules. And though we are keeping UMG, we will be keeping all the widgets within the primary project. We don't want to add that to our plugin. We don't want to give that to people. We want to let people make their own UMG. We're still going to be making certain calls to UMG from our plugin. So that's why we're including it here, so we have access to those libraries. And then finally, again, enhanced input. We could probably get away with not having enhanced input in here because I don't think we're making any calls. So if you want to exclude this, because remember, every module we add is going to add to the size of your project. If you don't have it, you're going to end up having some errors. Just remember, if at some point you need it and you don't include it and you can't figure out why, chances are likely you're not including the module. So I'm going to go ahead and leave this in here for now. I may come back later and delete this just because I think when I put this in here, I was originally going to include a character with my plugin, but afterwards decided I wasn't going to. As a matter of fact, I'm just gonna go ahead and delete that now. So that should be good. So if you don't need anything after that, after the UMG, if we do end up needing the enhanced input, then we will come back and do that later. And you'll see down here in the private dependencies, it's already defaulted to have the Core U object engine slate and slate core. And that should be all that we need for this particular file. Finally, in this video, I want to create a blueprint library. I want to use this library to have some lightweight code, mostly for static functions and or variables that we can use, that we can call in almost any class, or just kind of utility functions that just help us out, that can be used in multiple places, or just kind of generic functions. If you don't understand what a static function is, I'll quickly explain. A static function, a static variable. A static function belongs to a class instead of an instance. In other words, you don't actually have to instantiate it, right? We can just include it into the public, into the project's header file, and we'll just have access to it, right? So, but by that, it can be called without creating an instance. They're often used for utility functions, operations, and they don't depend on the state of a particular instance of the class. So we could just kind of call it. It doesn't matter. It doesn't have to be loaded, and it's just going to run some sort of calculation, or it's just going to do something for us and give us a return information for it. Now, with static variables, they're kind of the same thing, right? Except for with a static variable, you can have a static variable on any class that you want, but a static variable can't be changed. Once the project starts, that static variable cannot be changed. And if you have, let's use our item class for an example. If I put in a static integer of, let's give it a value of say 32, I put a static variable on there, integer 32, and every instance I make of that item, that particular variable will always be 32 no matter which class I call it on. It's constant. It takes up only one memory address, so it's good because like I just said, it only takes up one memory address, but it's there, it's persistent. The problem with that too as well is it's persistent, so it's going to be there until the game ends, so you're never going to get that memory back. So keep that in mind when you're creating static variables. They can be handy, but they're there forever for the life of the game state. Okay. And then also keep in mind too, with functions, a function can call variables, but it can only call static variables. It cannot call anything other than static. So static needs static. All right. So with that, let's go ahead and jump back into the project really quick, and let's create our blueprint library. So in here, I'm going to select the plugins. I don't want the content folder. Just within the plugins folder, I want to go tools, new C++ class. I am going to come down here. We are going to find blueprint function library, select that, hit next. Now within here, I'm going to keep it in the main hierarchy of the plugin project. So make sure here, what we're going to need to do is give your blueprint library a name. I'm going to call mine inventory statics, because this is going to primarily be just static functions and or variables that we're going to call a little bit later. And then come over here, and here now, if we select where it says the runtime, survival CPP YT runtime, select that, you're now going to see that we have the plugin in here as well. We now have two runtimes. So now, because I want this to be into my plugins folder, I want to select the TPG inventory system, whatever you named your plugin, then go ahead and select that runtime there. All right. And then you're going to see the path of it changed. So just make sure, verify your path, plugins, TPG inventory system, underscore source, right? So now it's going to create a new source folder for us, TPG inventory system. So now that we're creating our first C++ class within our plugin, it's just going to add these extra folder structures for us. Make sure the name's there. Don't worry about public or private. It's going to put it in public for us. That's why it's highlighted right there. Not a big deal. Go ahead and create class. And then once that's done, it should automatically open up in your IDE, and then it should automatically build the project for you. So the first thing we're going to build is we're going to go to the inventory statics.h. Let me close down all these other ones just to make it a little bit easier to see what's going on. And then I'm going to blow up the size of the font for you. Hopefully that's a little bit more visible to you. So the first thing we want to do, I want to create the ability to print a screen, right? As a developer, we want to print a screen quite frequently. And in C++, there's no real easy way to do that. So although the code we're going to enter here still requires a little bit of work from us to print a screen, it's going to be a whole lot easier than the original code. So we're in the inventory static.h. Under generated body, I'm going to create some space. Let's do public. And under the public, we're going to make this a public function. I'm going to call this static void print screen. I'm going to make it a const f string, and it's going to be passed by reference. I'm going to call this string. And the second one, we're going to go const f color. We're going to call this color. And we're going to give it a default value here. So that way, when we give a default value here in a parameter or in an argument, then that means we don't have to enter that when calling the function. It's an optional one. So the default color, give it whatever color you want. I'm going to give it a default color of green, comma, and I'm going to give it one more const float time equals 5.f. So I'm going to give it a default value on, or default time on screen of 5 seconds. Add our colon there. So again, we're going to create a static function called print string. The only thing we're required to give this function is a string. It's going to end up having to derive from the text macro, but we'll go over that in just a second. But we need a string that comes in. We can have the option to give it a color. Otherwise, it defaults to green, and then we can change its time as well, default 5. Whereas in-game, in Blueprints, the default's 2 seconds. If you want to leave it at 2 seconds, you can. I find usually 2 seconds is a little bit too short, but change that to whatever you want. So now let's go ahead and generate the definition, and it's just going to take everything, it's going to create it over here. I know Visual Studios has a similar functionality. Just go ahead and create the definition for you, and it's going to come over here, enter all this. So now what we need to do is go G-engine. We need to call the function add on screen debug message -1, which is going to be the key. Time to display, I'm going to call time, which is the time variable that we're passing in. And then the color will be the color variable that we're passing in, comma f string print f. And then the print f we need to have is text, and then %s, comma dereference the string variable from the parameters within. And then at the end, add your semicolon, and that should be it. That's all we need to do. So now whenever we pass in a string, it's going to come down here and it's going to print f, and it's going to take this string. Remember, we've got to dereference it here. Go ahead and check my fundamentals to understand dereferencing. And it's going to pass it in here, and it's going to print it to the screen for us. If we don't enter a color, that's fine. It's going to be green. Don't enter time, that's fine. It's going to be 5 seconds. So now let's go ahead and compile that. And then for me, I get this pop-up message that it may fail. I don't care. I know it could fail. It's just letting you know that, sometimes if you don't have a desired result, like I said earlier, you may still have to stop the editor. But for this, it should be fine. Just go ahead and build it. That way I don't get that error again. And then you see, I get this error right here. It pops up, error command. What this usually ends up meaning when you see this, come all the way down, it probably says code 6 at the end. Now, this is because of the fact that it didn't succeed there. So now if I stop the editor, if I close it out, wait for this to finish here, I'm going to hit compile again, and there we go, succeeded. So when you get that error, that's usually what it ends up meaning is just shut down your editor and start again. It happens quite frequently, and sometimes you won't even get that error. Just you'll notice that you don't get updated information, especially when you're just updating variables. You may not get that information within the editor. All right, so now we don't have really a place to call this function yet, so we can't really test it, but that was our first functionality. I want to go ahead and wrap this up in this video now. now. And in the next video, we're really going to start laying the groundwork and creating some functionality from our original code and converting what we already have in Blueprints into C++. And with that, I hope you guys found this useful. I hope you guys are excited for this series. I'm certainly excited for it. If you found it useful, go down, hit that like button. If you're new to the channel, subscribe while you're down there liking it. Hit that notification bell if you want to be updated whenever we drop a new video. And until the next time, peace.